right, so I'm going to go over just the principles of hot compost ecology before we go into management systems tomorrow. So I'm going to kind of just go over the essential principles of aerobic thermophilic composting, hot composting. So that's, temperature is a big deal in hot composting. Pathogen reduction standards are really important in the composting industry. And it really helps to mitigate people's fears around pathogens in composting if we do hot composting. And then we can feel more comfortable taking in all sorts of food waste, including meat, dairy, bones, if we're good about doing hot composting and getting up to temperatures of 130 to 150 degrees. So we're going to talk a little bit about how moisture, porosity, airflow plays into that, the role of bulk density, C to N, obviously, and feedstocks and recipes. This is mostly true that composting at all scales, the biology remains the same, from home scale to kind of industrial scale. But it's not quite exactly true. I think for like bin systems, when you layer your materials, they don't get as much coverage on the sides necessarily. So there's maybe a little bit more exposure of like the food waste on the sides. Whereas with like windrow or pile systems, you can get coverage like all around. So it's a little bit more preventative of odors and insulating. And there's kind of different properties of like thermal mass from like the physics perspective when the pile gets bigger. And the airflow can change because of that. But it is true that kind of the essential kind of biological processes are kind of the same, regardless of what scale you're composting at. So we're going to talk about how adjusting our carbon to nitrogen, moisture, and airflow changes our microbial dynamics. So I mentioned that hot composting is like an engineered process of decomposition that maximizes the speed of decomposition. So there's lots of different scales of composting. I want to mention mortality composting, which is a way to deal with like sick or dead animals on a farm. You can basically bury them in a giant static compost pile. And you don't turn it. It kind of has anaerobic pockets that form, but then it finishes in like a year or so. There's also vermicomposting, which we'll get to hear about tomorrow. And then there's other methods of dealing with organic waste as well, like bokashi, which is like a microbial culture. It's an anaerobic fermentation of food waste. And then there's also biochar, which is like a pyrolysis of organic materials into kind of a more of a matrix, like a porous matrix that is good for like nutrient absorption. And then anaerobic digestion is kind of a different process where the methane biogas is captured and converted into energy or electricity. So technically, there's a temperature rating called process to further reduce pathogens, and that requires your compost to reach 131 degrees for industry standards. And then they have kind of different requirements for whether you're aerated static pile or a windrow pile. So it has to remain at that temperature for 3 days for ASP. And then they require over 15 days for a windrow pile and to have 5 turnings. And this is for industrial scale where they're using kind of large machinery to manage their piles. And their piles are much larger in size too, so they're wanting to expose like all parts of the pile to that hot temperature. So the core of the pile is the part that gets the hottest. And so part of the turning is that you turn the outside in, inside out. And so all parts of the pile get exposed to the high heat, and that kills off human and plant pathogens and weed seeds. But our community compost piles generally are much smaller. There's still kind of an ambient temperature kind of blanket outside, and the core is still hotter. But I want to say that the temperature reach is maybe more thorough because it's a smaller pile. So anyway, I guess I am kind of questioning like the number of turnings in that regulation. that stands for aerated static pile, which is another type of compost that's more kind of technology intensive. Not necessarily, it's pretty basic, but basically there's different ways to do it. But underneath the compost pile, there's like pipes with holes in it, and that's attached to a big fan. And the fan blows air through the pile from underneath, and that helps to aerate and maintain the oxygen in the pile. But there's, and the idea is that it helps to save labor on turning, so you can aerate and oxygenate the pile without having to turn it. And so that does help, but they also tend to dry out a little bit more. Generally, you have to add more browns to the recipe for that. So there's different, there's like different nuances involved with the ASP system. And you ultimately still have to like move it, like you still have to turn it into like a maturing pile usually. So there's usually at least some like movement of that pile involved. So our general kind of like hot compost recipe is like a 25 to 30 to 1 C to N ratio, which translates to about a 1:1 to 2:1 browns to greens ratio. It's about a 50 to 60% moisture content. You could do a moisture squeeze test where you grab a handful of compost. It should feel quite damp in your hands, but when you squeeze it, maybe a drop or two of water comes out, but not much more than that. So that's like a quick feel hand squeeze moisture test. The bulk density is technically the weight over volume, and that speaks to how compact or not compact it is, and so it speaks to the airflow that you can get through the pile. And you don't want too much airflow because it's going to dry out, and you don't want too little airflow because then it is going to collect water and be compacted and become anaerobic, and you don't get good airflow through it. So when you set up all of these situations, according to kind of this recipe, you get heat generation and thermophilic processing. So this is kind of a generalized graph of the temperature process during hot composting. This is the temperature and the turning events. We start with our mesophilic phase. There's kind of, I think, like carbohydrates and sugars are being processed at this time, and then we get our proteins and lignins and fatty acids when it gets to the hot temperatures, and our formation of the more humic organic matter products is happening. When we set up the pile in the way that these decomposer microbes really like it, they all come in and feast on it and generate a lot of heat, and that's where we get our heat from. And then as the original waste material decomposes, the microbial activity slows down, and then the temperature drops, and we enter the cooling and maturation phase. And I feel like it is generally better to let it sit for another little bit to let the microbial ecology stabilize further before you use the compost. But oftentimes people are anxious to use compost, and we'll use it, even when it's hot. But it's just like more variable when it's like hot and immature, but I mean, you can still germinate and grow things in it. So this is kind of a look at the association between microbial biomass and temperature. So this is the temperature graph of the hot compost piles, and then this is the population of microbial organisms, microbial biomass in that hot compost piles. And so you can see they're very closely associated with the temperature curves. So this is just kind of a look at some of the different bacteria and organisms. These are the mesophilic organisms that exist in there. And there's some mesophilic fungi as well that are in the compost pile. So that first stage, we're degrading kind of simple sugars, starches, lipids, and they're being transformed into organic acids. We've got temperature rising from these metabolic activities. And then we enter our thermophilic stage, which is dominated by bacillus organisms, bacteria, and actinobacteria. So I mentioned that as like the white ashy material. When you open up your hot compost piles, you might see them. There's also some thermotolerant fungi So a lot of the other kind of organisms go dormant or die off during this phase where it's too hot for them. So it's kind of the hardy materials that are being degraded at this time. And then we go into our cooling and maturation phase, where it's more kind of humus like formation and tough material breakdown. So higher temperatures are not necessarily good. After about 160 degrees, we might be losing microbial diversity and beneficial organisms. So we just need to reach 131 for our pathogen kill temperature. So kind of keeping our temperature within that 130 to 160 range is good. I don't know why, but I really like 140. That's like my favorite temperature. So I was shoot for that. Porosity and airflow. So free airspace is the idea that that's the pore space that's not occupied by water or liquid. So because the compost pile is weighted down, you have more free airspace at the top and more kind of compaction and water at the bottom. So that's why we always start our compost piles with mulch at the bottom to kind of facilitate airflow and water absorption or absorption of leachate. Bulk density is mass over volume. We could talk about that later. The C to N ratio mentioned. So some examples of these feedstock ratios, it's like everything has more carbon molecules in it than nitrogen molecules. So everything is going to have like, a higher C to N ratio. But when we're talking about high carbon versus high nitrogen materials, that's like a relative statement. So like grass clippings and manure, like 10 to 20 C to N ratio, whereas wood chips are like 300 or 400. So relatively speaking, wood chips are high carbon material. Okay, so odors come from anaerobic conditions. Everybody's afraid of odors, but it's really easy to take care of them. Pretty much all you need is wood chips. Anything that smells, just cover it up in wood chips. It's just got this ability to absorb odors and neutralize odors. And you want to keep your carbon nitrogen ratio balanced. Generally, you don't want too much nitrogen because that's generally more wet and smelly and compact and more likely to lead to anaerobic issues. So if you do open up your pile and find that, then you want to mix in more wood chips if there's too much food waste. And that's it. Like we typically don't have major odor issues at any of our sites because we're like managing it with like wood chips and balancing our nitrogen ratios. Biofilter is a kind of fancy term for some compound that absorbs odors. Okay, so general hot compost recipe. We start with a layer of wood chips, 3 to 4 inches, then a layer of food waste, 3 to 4 inches. We cap lightly with manure, coffee grounds, or brewery waste, about 1 to 2 inches, and then cap with wood chips, and we want to cover everything with wood chips from the sides and the top. The turning frequency is something to think about. Introduces oxygen, makes the decomposition go faster. If you're turning all the time, you can get compost really quickly, but it also disrupts your microbial community structure. So I kind of like to keep it a balance, maybe every 6 weeks or so to turn the pile. So people have different ideas and approaches to that. So just to wrap it up, just all of these different things are thinking about how the ecology informs your management and how your management affects your ecology.